بسم الله الرحمن الرحيم الحمد لله رب العالمين والصلاة والسلام على سيدنا ومولانا محمد وعلى آل سيدنا ومولانا محمد وبارك وسلم. اللهم ربنا أرنا الحق حقا وارزقنا اتباعه وأرنا الباطل باطلا وارزقنا اجتنابه. اللهم أرنا حقائق الأشياء كما هي ربنا زدنا علما وعملا وإخلاصا يا رب العالمين. اللهم انصر أولياءك في مشارق الأرض ومغاربها. اللهم انصرهم على عدوك وعدوهم إنك على كل شيء قدير. اللهم فرج عنا وعن إخواننا في مشارق الأرض ومغاربها. اللهم نفس كربنا وكربهم وثبت أقدامنا وأقدامهم والطف بنا وبهم يا أرحم الراحمين. وصل وسلم على سيدنا ومولانا محمد وعلى آل سيدنا ومولانا محمد وبارك وسلم عليه. سبحان ربك رب العزة عما يصفون وسلام على المرسلين والحمد لله رب العالمين برحمتك يا أرحم الراحمين آمين. Okay, so we had started looking at Allama Iqbal's discussion of Einstein's conception of space, etc. But the session wasn't recorded properly, so the session doesn't have voice. I forgot to turn on the volume. So I'll just try to repeat, to go through the same material we went through in the last session. I don't know how much would be the same. That's why I uploaded the video without volume, without voice, because at least you can see what I had written. Because I might not talk. I might end up talking about something not totally different, but I might miss something, I might add something, etc. So, although I'm going to go over the same material, so let's see. So with Einstein, space is real. So what I said was that real can be goes with ideal as well as imaginary, fictitious, etc. So for Einstein, space is real, so it is not fictitious. But so real in what sense? Allama Iqbal doesn't make it clear. But relative to observer, it is not as if relative. The concept of relative space was not used by unknown to Newton. So relative to the observer, when we talk about velocity, we always in acceleration we are talking about we are measuring it relative to observer, obviously, or relative to other things. But the real question is whether beyond that or apart from that there is absolute space or not. And if there is absolute if there is absolute space, what is its nature? What is the conception? So it's not just relative or absolute space, but what is your conception of space? What is Einstein's conception of space? What is Newton's conception of space? And how they are different, and whether they have similarities. So he rejects the Newtonian concept of absolute space. Absolute space. Now this will come to what is Newtonian absolute space. The object observed is variable. It is relative to the observer, its mass, shape, and such change. as the observer's position and speeds change. Movement and rest too are relative to the observer. There is therefore no such thing as self-subsistent. I mean, that is one of his main themes in this chapter. There is therefore no such thing as self-subsistent materiality of classical physics. I don't think this follows from Einstein's views. I don't think Einstein rejects self-subsistent materiality, but obviously it depends on what you mean by self-subsistent, but we'll come back to that. Let's first try to understand the main parallels between Einstein and Newton's views about space and main differences. So we'll go through so for Newton's conception, Newton believes in absolute space, and on the other hand, Leibniz, for example. So I think the first thing is we should differentiate between relative and absolute. This is one contrast. There's another contrast, relative with relational. So this is, at least to start with, this is the Einstein-Newton debate, let's say. But absolute with relational, this is Newton-Leibniz. So this is important to remember. These are two different things. They might be related, but they are two different things. Relative versus relational, or absolute versus relational rather, and absolute versus relative. This is Einstein-Newton, this is Newton and Leibniz. Okay, so let's so there are a few things. The conception of space. As compared to relative and absolute motion. So your conception of space is going to affect whether you believe the motion is relative or absolute, or if there can be an absolute motion. But conceptually they are two different things, conception of space and whether motion is relative or absolute. Okay, so let's look at conception of space part first. For Newton, space is absolute. In what sense? It doesn't mean that he didn't believe in relative space, but there is an absolute space. In what sense? Firstly, for Newton, space is separate from the object. From the objects in the universe. So, and he's not very clear about what he means by space, really, but his conception of space is sort of a container. If you remember his famous bucket experiment or thought experiment. So, a bucket water. So, you can think of bucket as a space and water as things. So in a similar way, space is for Newton, space is a container in which the things in the world exist. And so you can see that even if, for example, we take out water from the bucket is still there. So that's Newton's concept. And similarly, Newton time is also absolute in the sense that it is separate from things in the world. It exists independently. So for Newton, space and space by space where here we mean, and you can include time as well, even though we are not talking about time. They're absolute in the sense that they exist independently. Of matter, events, and they both provide universal context for space and time, for all motion and change. That's why we can have absolute motion, because we can always measure, at least in principle, motion and change against this absolute backdrop. Okay. So now Newton's absolute space is contrasted first, space and time, not with Einstein, but Leibniz. Because Leibniz believes in, his conception of space is relational conception of space. A relational conception of space. Meaning, for Leibniz, space is the relationship between or among things, and so is time. So if there are so the structure of the relationship between things and the world, that's what space is. So if we take out all the things from the universe, there won't be any space. Won't be any space. So space and time for Leibniz is not independent of matter and event. I mean, I'm putting events because quantum physics, for example, talks in terms of events rather than matter. Now, for Leibniz, on the other hand, in this sense, for Leibniz, space is not an entity or a thing. On the other hand, for Newton, it is a thing. So it's not an entity, but a structure in a sense, a relational structure among the objects. So if there's no independent space, independent of matter, and there's no absolute space, there's no independent space, which are not, these two are not the same thing, but in this context, they are the same. For Leibniz, motion is also relative. Because motion for him is relationship between objects, or objects and subjects, because there is no independent space apart from objects, and I guess subjects as well, against whose context of the backdrop we can measure motion, irrespective of whether that independent space is absolute or not. So that's the third. So both Newton and Leibniz had conceptions of space and time, and from those conceptions emerges whether they believe in relative and absolute, only relative motion or absolute motion. So Leibniz only believe in relative motion. On the other hand, obviously Newton also believe in relative motion, but he also believe that there's something called absolute motion. Now we can come to Einstein. Now, for Einstein's conception of space and time, we should talk about space, because that's one concept for him, but we'll just ignore this for the purpose of this description. So Einstein's conception of space. I don't think Einstein is Leibnizian. He doesn't have a relational concept of space and time. Even though, as we'll see, he agrees with Leibniz. That there's no absolute motion. And he also agrees with Leibniz that space and time are not independent of matter. Okay, so for that we probably have to go to Descartes, because for Descartes, if you remember, describe space as extension. So space is basically a dimension of matter. So in this sense, space is equated with, in a way, a dimension of matter, extension. So here space is not relational, although there is a relational space as well, but it is non-relational space in the sense that a conception, because it's equated with matter, one of the dimension of matter. So you have extension. So matter for a space for Descartes is extension. So in that sense, Descartes' position is similar to Newton in some respect, and similar to Leibniz in some respect. His position is similar to Newton in the sense that he doesn't believe in relational conception of space. He has some spaces, a thing which is extension, but he agrees with Leibniz that it is not independent of matter. So in that, or even in that, he is different from Newton. And I guess you can't, he would, I'm not sure, but I'm just guessing here, Descartes won't have a absolute conception of motion, because space is not independent of matter, so there's no absolute space in that sense. So there is no absolute space, at least we can't measure motion in the context of absolute space. And also he would agree with Leibniz that if all matter is taken out of the world, there won't be any space, because space is the dimension of matter. Okay, now from this we can see that Einstein, in some ways, so you have Newton, you have Descartes, you have Leibniz. In some ways, he agrees with Descartes, for example, that space is basically a property of matter in a sense. So in that sense, he doesn't believe in relational concept of, although, or at least it would seem a relational conception of space as in Leibniz. So in that sense, he also agrees with Newton in that he doesn't believe in a relational concept of space. For them, space is a thing, not a structure. On the other hand, because space is so, on the other hand, he agrees with Leibniz and Descartes, Einstein, that space is not independent of matter. So in this he disagrees with Newton, and obviously he would reject absolute conception of motion as well, because there is no absolute vantage point. Although space is not relational, there is no absolute space, there is no space independent of matter. So we can only measure motion in relation to objects and subjects, etc. So I think that's pretty bad. I mean, I explained this time in a different way than the last time, but at least my notes are still there, even though the voice is not there in the last session. So this provides us with the backdrop of against which we can try to understand what Iqbal is talking about in the next session, inshallah. Subhanakallahumma wa bihamdika nashhadu an la ilaha illa anta nastaghfiruka wa natubu. Salli wa sallim ala Sayyidina Muhammad wa ala ali Sayyidina Muhammad wa barik wa sallim.